All right, looking at the recursive and explicit formulas for a geometric sequence. So a geometric sequence is either increasing or decreasing by a different amount, but it has something called a common ratio. And so that's the first thing we want to be able to find. So let's list the two formulas. So here's the recursive formula. Okay, and the recursive formula is a sub n equals a sub n minus 1 times r, and the explicit formula, which is the more useful of the two, is a sub n equals a sub 1 times r to the n minus 1. Okay. So really all I need to find is the r and a sub 1 for the explicit formula. Okay. So r can be found from doing a sub n plus 1 all over a sub n, or that's just like a fancy way of saying the right one over the left one. Okay, so I get that from when I mean right or left, so I'm talking about this one on top of that one, or that one on top of that one, that one. It's the same thing. So I'm going to say r, I'm going to go ahead and just use these first two, is I'm going to do 18 divided by 6, and that's 3. Okay, and it doesn't matter. If I take the next two and I divide those two out, that's also 3. So it's called a common ratio because it's the same for all of them. Okay, so what that means is this common ratio says if I had the first term, I multiply it by 3 to get the next one, then multiply by 3, multiply by 3, multiply by 3. Okay, so if I look at my recursive formula, that's all I really need to plug in right there. So my recursive formula is a sub n equals a sub n minus 1 times 3. So it says if I want to find a term, I'd take the term before and multiply by 3. So there's half of it done right there. Okay. Now for the explicit formula, I need to find the first term, and that's just by looking up here at the sequence and realize that it's 6. So the explicit formula is a sub n equals 6 times r to the n minus 1, and that is my recursive formula. Okay. And realizing that I do not multiply these numbers first when I actually use that. So let's look at another one. So we're going to do the same thing here. We're going to find we're just going to find the explicit formula actually, and then when we're done is we're going to find the fifth term. Okay, and we're going to find the fifth term. So first things first, I'm going to find my common ratio, and that's the right one over that one, and that's going to be 1/5. So r equals 1/5 after I reduce it. Okay, so that's my common ratio. My first term, a sub 1, is 425. Okay, just by looking at it. So now I'm going to write the explicit formula. And the explicit formula is a sub n equals the first term times the common ratio to the n minus 1. Okay, so there it is. So now how do I use it? Okay, well, it's a function. So I plug in a 5 for the n, and that will give me the fifth term. So if I want to find a sub 5, which is my notation for the fifth term, I say that equals 425 times 1 over 5 to the 5 minus 1. And then I work this out. And I say 425 times 1 to the 4th, because 5 minus 1 is 4, all over 5 to the 4th, right? Because this right here is going to be 1 to the 4th, just this part right here. So I put the power on both of those. And then I say 425 times 1 over, and then 5 to the 4th is 625. All right, 625. So I multiply straight across, and I get 425 all over 625. Okay, and I can divide both of those by at least 25. So 425 divided by 25 is 17. And 625 divided by 25 is 25. So that is my fifth term.